even got a timer here, so I know when I have to get off the stage. Good morning, everyone. My name is Robert Stewart. I'm the Facility Engineering Manager with Irving Shipbuilding, and I've been involved with the Modernization project at Halifax Shipyard. So today we're going to talk to everyone about Halifax Shipyard, the modernization, and how we utilize BIM in that process. So for those of you who haven't seen the site probably from the air, this is our new assembly hall and module hall that we built at Halifax Shipyard. That's been constructed between 2012 and this year. We're actually in the process of wrapping up the final stages of this project, which is our ship erection platform. But over the past couple of years, we've definitely made a dramatic change on the waterfront. The building that you're seeing in front of you there is over 408 meters long. It's 70 meters high, and at its highest point, we're the equivalent of a 16-story building. You may not get that perspective when you're driving by on Barrington Street, but it's a very large building covering over 7 acres of land. So we're quite proud of it, and there was a lot of hard work that went in to do that project. In order to accomplish this work, obviously you need a team. Our core project team consisted of ourselves, Irving Shipbuilding, with the Facility Modernization team. We had a cross-functional group from within our company that worked on the design of this new facility, ensuring that it met the requirements of both production, IT, security requirements, and the facility itself. Our prime consultant was Hatchmont McDonald, now Hatch, and they led the effort on the design. Our new creation of the 3D model and BIM information was carried out by Hatch, and they spent over 97,000 man-hours on design completing this building. So it was a very significant effort for us. And then of course we had Ellis Dawn as our construction manager. They were basically our boots on the ground, providing us with the field supervision and construction management practices that allowed us to undertake such a massive project on a very tight timeline. This group worked very closely together on a weekly basis, daily really, and it was a key part of our success with the project. Beyond that, obviously, the local contracting force, as well as contractors from around the world and vendors, were key to our success with the project and made sure that we got a building that is going to support all our requirements for the NSPS program. So BIM and facility modernization. I wanted to start off talking a bit about kind of the three perspectives that our core project team saw with BIM. So we've got the ISI consultant and construction manager perspective. From our point of view, from Irving directly, this provided the team with an efficient method to review the design and get stakeholder approval. Our senior leadership group is very visual. When they like to see something, see, feel, touch if they can before they make a decision. The 3D model and the BIM information that we were able to provide them as part of the project made that really improved our decision-making timeline. We were under a tight schedule to get this building up and running. We obviously wanted to get started on cutting steel for the new ships, and anything that we could do to speed up our decision making for key stakeholders was a big advantage to us. From the consultant perspective, it was a steep learning curve getting all the team proficient. With Hatch, a number of the resources they were using on the job had mainly worked in 2D prior to this project, so we were getting them up to speed on a new software, as well as making sure that all the information that we needed was passed on to the team. In the end, though, it provided a huge benefit to our design effort. It allowed us to basically ensure that what we did in the field made sense, and that we were identifying issues early enough in the job that we could make changes. And then obviously from the construction manager perspective, aid in the coordination of construction and provided meetings for clash identification. When you have a rapid project where you have many multiple disciplines and trades working in the same space, being able to identify if that duct is going to hit that pipe ahead of time is critical, because as we all know, once that's found in the field, it usually means a stop of construction and then a multi-hour or multi-day event to try and resolve the issue. So all of this provided, BIM provided us a lot of advantages on this project. So why did we decide to use BIM? Irving Shipbuilding and JD Irving as a whole has taken on a number of large-scale projects in the past. We've done it successfully, but for this project in particular, we wanted to kind of go to the next step. And we had our senior project leadership had a lot of discussions with different people in the area. We talked actually with a bit with David Mayles on what he saw going on with different design activities in the area and that. And we came to the conclusion that we wanted to use a cutting-edge design tool for the project. So we wanted to make sure that what we were doing here was going to use the latest and most efficient design tools for undertaking the project. We saw a huge advantage of information management for maintenance of the facility in the long term. So by building this model, inputting the information into it that we have, we feel that as we go forward and start to maintain the facility or create renovations and upgrades on the project, we'll have a great starting point to do that. And then we'll keep building on this for years to come. And then, of course, we wanted that 3D dimensional representation for the facility for planning and design review. Nothing makes it easier to bring a group of contractors in and explain what you want them to build if you can show them a picture, do a model fly through, and show them, at the end of the day, how things are supposed to look. So, obviously, we gained a lot of advantages from using BIM as part of the project. You can see we were able to achieve rapid decision making by our senior management through the use of model shots. As you can kind of see between the two examples here, what was done in the model and what ended up happening in real life were very close. So we're very pleased with how concurrent the two real life and model worked out together to be. Collision avoidance during construction and design using BIM consultant specialist. We had a representative from Hatch on site with us for the duration of the construction of the project, and that one of his main roles was to work with our consultants and contractors to make sure that as we identified issues in the field, they could be resolved quickly and that we could get a solution out to the contractor to move forward. If we were waiting for that to be kind of shipped back to the office, dealt with, and then brought back to site, we would have had significant delays. So we saw a definite advantage in having an on-site BIM consultant right there to work with us throughout the course of the project. And then asset numbering. Now, seems like a simple thing, but just the amount of new infrastructure that was put into this building, making sure that everything was properly numbered, labeled, information was inputted, was a huge undertaking. We wanted to make sure that we had that information in the model so that we could extract that data in the future and get to a point where we could use it as we maintain the facility. So while it seems like a simple point, it's a huge information advantage for us. Now, obviously, there was challenges for us to overcome with BIM in our group. One, for all parties, was a lack of familiarity with BIM by the consultant, contractors, and owners' representatives. Both Hatch and Ellis Don have worked on BIM projects before, but we were bringing it really for the first time for a big way here in the Maritimes. We had to get a number of people up to speed on it, and we had to make sure that they had the technical knowledge to use the program. From our own perspective, from Irving's perspective, we had heard of BIM. We saw it as an advantage, but we didn't fully understand the full capabilities of BIM at the start of the project. So it was a learning curve for us as well to really get up to speed and understand how we can use this. But it's proved very beneficial. Lack of local resources to implement the model, had to learn as we went. That was both Hatch bringing some of their team up to speed, but also local contractors and vendors not necessarily having the familiarity of BIM, being able to work with the model themselves and requiring us to kind of support them more than we would have ideally liked to have done. But as we moved through the project and we got more experience on what we were looking for, we could work with those people and get things moving a lot faster. And then, of course, there is a much more upfront design time. When you're on a fast-track project, we want to get in the ground as quickly as we can. We want to start building. That's kind of what our function is for Irving, and we want to make that happen quickly. And you do spend more time up front getting the model right before you can start creating those 2D drawings that are so important to hand out to the supervisor in the field. So it was a learning opportunity for us to recognize that at the start of the project, we may have more time to kind of get that model to a point where we can start extracting the drawings that we need to go out in the field. But by spending that time up front, we get a much better product at the end of the day. And when we have changes as the design proceeds, they're more rapidly propagated through everything that we're doing. So that was a learning experience for us, but something that we will account for in the future. So now we have this model. It's a very detailed model. Every time I watch one of our technicians bring the model up, I kind of get a little impatient while I wait for it to kind of come online. But once it's there, it's got a huge amount of data. But to use this model, it's only as good as the information that's maintained in it. So for us, we want to make sure that we've got a lot of discipline to ensure the modifications we capture in the field are put into the model. While it's a brand new facility, already there's tweaks and changes that you want to make as production comes online, as they get more experience with the building and start to recognize areas where they could potentially have improvement. So you always get that wish list. There's also the natural organic growth of the building. When we built this facility, it was built both for the AOPS program, but also for CSC, which is the Canadian Surface Combatants. So we allowed for future growth, both in staffing levels, workshop requirements, things like that. But we've already started to grow into some of that space, and we want to make sure that anything that we do there is correctly captured in the model. Because if we lose basically the connect between what's in the field and what's in the model, the value will go down substantially for us. And then, of course, we require technical resources capable of manipulating the model and making changes. For us, what that meant was bringing one of our engineering technicians up to speed on the use of BIM, making sure that they had opportunities to use the program, model with the program, and be able to manipulate the program. So we've done that, and it gives us a huge advantage internally to be able to maintain that model. And then, as always, things change rapidly. For many people, what I noticed on the tour yesterday, for many people, you drive by our building, it's a large white building, it's all closed in, and the question I'm most commonly asked is, are you actually building anything in there yet? And in reality, for those of you who went on the tour, and as you can see from these photos, that we are quite involved in the building of the first ship for the AOPS class of vessels. So there's a huge amount of activity in there, which also equates to a huge amount of changes that need to be made to support production as they shift down along the assembly of the first vessel. So that's very challenging for us to maintain in this rapidly changing environment, but it has definitely, if we can do that, it's going to pay off in big dividends. So we undertook a BIM project, but where do we see ourselves going in the future with BIM? From ISI, we want to get to the point where we can create models that are shared between the consultant and the contractor to provide the most accurate information to the client. We would really like to see it on the next time we use BIM on a large-scale project, where the contractors and vendors are able to more easily manipulate or provide information into that model. It would save us a lot of time if someone can take their section of the model or the area that they're working in, input their data, we can bring it back to the central model and kind of make sure that everything fits from the design philosophy that we're trying to achieve for the project. If we can do that, that's going to be, in our opinion, a huge advantage to making things move more smoothly and rapidly. From the consultant perspective, we've got to increase the amount of embedded data in the model so that it can be used for scheduling, labor, material estimating, along with in-depth facility maintenance. So, talking with the people at Hatch, what they'd really like to get to is where we've got this model to the point where it's working well for doing all kinds of material takeoffs. We're able to do a more effective job of scheduling multiple trades in the construction site. And we've got that data so that when, at the end of the day, the project team hands this over to ongoing maintenance and facilities upgrade or upkeep, we are able to ensure that the data is there to support that. And then, of course, from the construction manager perspective, they want to use BIM to model to create savings within the tendering process. And as the owner, I can say we'd like to see them create savings in the tendering process as well. Anything that we can kind of take the risk or unknowns out of a bid process so that contractors are more confident in giving us tighter numbers or more confident in ensuring that that what we're asking for is correctly reflected in our drawings, the better off we are. And then we want to bring that asset data into the model to help the client manage the facility for years to come. Obviously, this facility is brand new. In perspective, we brought it online last summer, but we're intending to use it, for decades to come. So we want to make sure that we have the data there so that we can provide the support we need. So for conclusion, BIM was an advantage to the Halifax Shipyard facility modernization. I think everyone who worked on the project would agree that having that model and having that information is what was a key contributor, what allowed us to have the success we did in rapidly completing a project in a very tight timeline. But more importantly, that it exposed JD Irving as a whole to the use of BIM, and we realized that going forward for projects, this is how we want to move forward. So while our major core project team is disbanded, other than what we're trying to finish up at the north end of the yard, people have gone back to their different assignments around the company, and they now recognize this is how we want to move forward. So people that were here that are now back in St. John are saying to themselves, table stakes for us now, we want to have a 3D model, we want to get that information into the model, because that's how we're going to make things effective in the field and hopefully drive down our costs as we go forward building some of these new infrastructure improvements that we need across the company. So it's definitely within JD Irving and within Irving Shipbuilding and the facilities and project management group, we are a big supporter of BIM and the advantages it brings to you as a project management team. So with that being said, I want to say thank you on that, and just to kind of give everyone who wasn't able to go on the tour yesterday a little more perspective of what the building is, what we're doing in the building. We have a short video that we'd like to show that will kind of give everyone a kind of a glimpse of what's inside.
For almost 130 years, the Halifax Shipyard has shaped Canada's naval history, and to date, Irving Shipbuilding has built 80% of Canada's current fleet. Now, a new chapter is underway. It is our privilege and responsibility to build the next generation of ships for Canada at the largest and most modern facility in North America. A building over 4 football fields long, located adjacent to the Royal Canadian Navy Dockyard. From coast to coast to coast, Canadians are benefiting as this project grows our economy and creates new opportunities for research and development. It starts at our facility in Dartmouth, Nova Scotia, where massive steel plates begin their transformation. Fueled by information from a digital 3D model, these plates are cut to measure on state-of-the-art equipment with incredible precision, welded into I-beams, and curved into exact shapes. Specific forms are cut as needed, and pipes are custom crafted on-site. Each part is labeled and kitted by job for transport to where construction continues at our Halifax shipyard. There, a team of highly trained shipbuilders assemble the parts into their final forms with cutting-edge equipment in North America's largest undercover shipbuilding facility, an ultra-modern workplace designed for ergonomic efficiency and safety. This work is conducted using the most modern processes to ensure these complex ships for Canada are completed on time and on budget. First, plates are marked, welded, cut, and assembled into deck and bulkhead panels. Once outfitting, welding, and painting are complete, these units are assembled into blocks. Special equipment and hundreds of kilometers of cable are installed as these blocks are joined together to form megablocks. These megablocks weigh several hundred tons. The complex outfitting process continues, but on a larger scale as more of the ship comes together. The megablocks are moved to the land level on heavy lift transporters to be joined. Final testing is completed as the ship is brought to life. At this time, compartments also get ready for commissioning. The ship then moves using heavy lift transporters onto a launchway barge. The barge is towed to open water where the ship is floated during a controlled launch. After launching, the commissioning of compartments and equipment continues as the ship prepares for sea trials and delivery to the Royal Canadian Navy. But ships are just part of the story. The economic and social impact of this project will benefit Canadians for generations. Over 1,000 companies, large and small across Canada, have registered to work with us. And Canada's Industrial Regional Benefits Program ensures that we spend 100% of the value of our projects inside Canada. That means for every dollar we spend internationally, Irving Shipbuilding, or one of our top-level suppliers, invests the same amount here at home. These investments are already fueling jobs and research at companies and universities across the country. In addition, we are investing in people, bringing in international talent, and training our current and future workforce. A new generation of shipbuilders is being trained with a focus on diversity. They will follow through on our 30-year commitment to delivering the best ships for those who serve. It is our honor to partner with the Royal Canadian Navy to help strengthen our country's workforce and economy, and to ensure Canada can take its place on the global stage.
The work is underway. The ships are being built by the best workers, with the best equipment, in the best facilities. We are constructing a legacy for our Navy and our country. It is indeed a great day to be a shipbuilder.
Thank you very much.
All right, Robert's not going to be here for the rest of the day, so it's a very short walk from here to the stairs, so if you want to grab him before he leaves. Thank you very much.
Great, thank you very much. Thank you, everyone.
Can I ask you a question? Your ship looked like a big BIM project.
Yes.
What tools were used for that?
Well, yes, the ship is actually a very big BIM project in that it's a complete 3D model where we've inputted the data for the ship itself into that model so that we can pull construction materials, takeoffs, all of that sort of thing. So it's a number of different computer programs that have been brought together. So I'm not sure of the exact software packages they're using, but yes, just as that kind of highlights, basically everything we're doing for the design of our ship is also being done in a 3D model with a BIM capability, or I guess maybe a SIM capability, ship information management. But that is part of what we're doing for the new vessels. And for those of you who were on the tour yesterday, obviously the block that you saw come out in the video, that was the block that you saw coming together at the north end of the module hall. So that's what we're assembling right now, is that center block. Okay, thank you very much.
Thanks, Robert. For those of you who have interest, there's a fellow in the audience, I'm going to ask him to stand up. Jason Molnar. Where's Jason? This individual here was very involved in the development of the BIM model of that facility, so if you want to go pick his brain, I'm sure he can share a few tips and tricks with you, so thanks a lot.